Hello,
Good
can
evening,
you
sir.
hear me? Yeah, good evening. Okay, so this week we are going to start with the topics of AOD, straight lines, and circles. So, first we'll try to cover the basic theory. Uh, AOD is what we'll discuss today, and then in a future class, we'll discuss theory for straight lines and circles as well. Uh, I have already shared the sheets in the group. So I hope everyone has seen the sheets that are there for this week. So I think there are total four sheets, I think, for these three chapters. So what you should do over the coming week is try to solve the sheets, try to solve them, and also try PYQs on these chapters. Right? So that is the work that you have to do. Uh, okay, so for today's session, we'll begin with applications of derivatives. So I'm going to assume that all of you already know how to do differentiation and all, right? So that should be
Yes,
something that you already are familiar with. And we'll
yes,
start
sir.
with the topic on applications of derivatives. The first major application is finding tangent and normal to a curve. And that also helps us in coordinate geometry. So you can find tangents and normals to curves in coordinate using the calculus method. And if you have y is equal to f of x, then dy by dx or is equal to f dash x is basically the slope of the tangent to the curve at a particular point. So if I want the slope of the tangent at a particular point, let's say the point was some h comma k. So what I will do is I will find dy by dx, and in that I will evaluate that at x is equal to h. So basically I have to find f dash h. F dash h will be the slope of the tangent at this point. Now that you know the slope of the tangent, equation of the tangent will automatically pass through this point and have this slope. Therefore, equation of tangent will become y minus k is equal to f dash h multiplied by x minus h. An equation of normal will be basically y minus k is equal to minus 1 by f dash h into x minus h. Because the normal is going to be always perpendicular to the tangent, so its slope will be minus 1 by slope of the tangent. So all of this is standard stuff, very basic, and you should already know all this. I hope everybody is familiar with this stuff, right? The
Yes, sir.
next, the next idea here is the concept of or the values of subtangent and subnormal and length of tangent and length of normal. So these are just some terminology that you should be familiar with. Subtangent, subnormal, length of tangent, and length of normal. So in general, we will do it for a general case where we have a y is equal to fx curve, something like this. Let's say this is my x and y axis. And let's say the point is this point P. This is the point P at which I want to make my tangent and normal. So the tangent equation would be, the tangent graph would be something like this, a straight line graph, and the normal graph would be perpendicular to it and something like this. So let's say this is my tangent, and let's say the tangent line intersects the x-axis at a point T, and this is the normal line, which is 90-degree, and that intersects the x-axis at point N. So if that is the case, then we can also drop a perpendicular from P to the x-axis, and let's call this point M. So this is perpendicular from P to the x-axis. So if P point was some x1, y1, x1 comma y1, and the curve was y is equal to f of x. Obviously, we know that y1 is equal to f of x1. That is the first thing that we know because P lies on the curve. Now, what is subtangent? Subtangent is basically this distance, Tn. Subtangent is this distance. Subnormal is this distance, Mn. And what are the length of the tangents? Length of the tangent is Pt. Length of tangent is equal to Pt, and length of normal is Pn. So basically, in this figure, you should be able to recognize these four distances. And these four distances are given names: subtangent, subnormal, length of tangent, and length of normal. Now, once you understand this for a general case like this, any particular y is equal to fx, you can find subtangent, subnormal. What you just need to understand is this diagram. Is the diagram clear what is happening here?
Yes, sir.
Yes, sir.
So M point will be what? M point will be x1 comma 0, right? Correct? And we can find the point T and the point N because we know how to write the equation of T, a PT tangent is basically y minus y1 is equal to f dash of x1, x minus x1. This is the equation of the tangent. So when will it intersect the x-axis? When y will be 0, right? So basically, if you put y0 here, 0 minus y1 is equal to f dash x1, x minus x1, and you are getting minus y1 by f dash x1 plus x1. So this coordinate becomes x1 minus y1 by f dash x1, comma 0. Do you understand that that is your t?
Yes, sir.
Similarly, if you write the equation of the normal, it would have been y minus y1 is minus 1 by f dash x1 multiplied by x minus x1. And if you put 0 here for y is equal to 0, you will get the coordinates of n. And that would become y1 into f dash x1 plus x1. So it is x1 plus y1 into f dash x1 whole comma 0. This is the point n. This is the point t. This is the point m. So now it is obvious how to find the distances and all. You can find all the relevant distances, right? For example, subtangent would be x1 minus this. So can you see that subtangent length is coming y1 by f dash x1? Right?
Sir.
Similarly, subnormal would be this coordinate minus x1. So it will be y1 into f dash x1. So what I'm getting is subtangent is coming y1 by f dash x1 and subnormal is coming y1 multiplied by f dash x1. You don't have to remember it, but you have to understand how we got it. I hope that is clear to everyone so far.
Yes, sir.
Also, remember that this angle theta, tan theta is what? Tan theta is the slope of the tangent line. So it is going to be f dash x1. So if f dash x1 is tan theta, and I know the length of MT, I can find the length PT directly, right?
Yes, sir.
Because of a right angle triangle, I can say MT by PT is cos theta. So I know MT length is this subtangent. So MT by PT is equal to cos theta, and therefore PT will come length of tangent in terms of the theta, where tan theta is equal to f dash x1. Correct? Nothing in this section has to be remembered. All you have to do is to understand the diagram and be able to find things yourself. Is it clear so far what we have discussed right now?
Yes, sir.
Okay, so if it is clear, then solve this question. find the value of k, so that the length of subnormal at any point on the curve y is equal to a power 1 minus k multiplied by x bar k is a constant. That is the question.
So k equal to 1 by 2.
K is equal to 1 by 2, but here you are using a formula, right?
Yes,
You are
sir.
using y1 into f dash x1, correct?
Yes, sir.
But don't always depend on the formula because you might forget the formula at some stage, right? Like this is subnormal and this is subtangent. If you can remember it in a guaranteed way, great. But if you forget the formula, you need to know the figure and be able to do it yourself. You need to understand the figure, right?
Yes, sir.
And if subnormal is supposed to be constant, then this part has to be at y1 and x1, this part has to become a constant, right? So it should not depend on x1 or y1. Correct?
Yes, sir.
When you take the derivative here, it should be such that the value of the subnormal does not depend on the coordinate of the point P. Then only it can be said to be constant. No, otherwise it will keep changing with different coordinates, right? I hope everyone else is also understanding what is happening.
Yes, sir.
So if anybody is not understanding something, please let me know because these are very fundamental basic things. If there is some issue, you need to get it sorted today only. You can't wait for later. So, okay, that was easy. The next topic is angle between two curves. And this is very important, not just in this particular topic, but also when we discuss circles, you will have to think about angle of intersection between two circles. So what is the angle between two curves? Let's say one curve is like this, another curve is like this. And these curves are intersecting at point P and Q. If they are intersecting at point P and Q, I need to find out the angle of intersection. Angle of intersection. Let's call this curve 1 and this one is curve 2. Of curve 1 and curve 2 at P and at Q. So how do you think we will define an angle of intersection between these two curves? What's the logic? Anybody knows what is the logic of angle of intersection?
The angle between the tangents to the intersecting points.
Right. So, for example, point P is a point that lies on both the circles, both the curves. So you can make a tangent to curve 2 at point P, that is, let's say T2, and you can also make a tangent to curve 1 at point P, and that is my T1, right? The angle between two curves will be defined as the angle between the tangent. So we have to find the angle between T1 and T2 lines. This is equal to angle between the tangents. And obviously there will be two different tangents because the curves are intersecting. If the curves were touching each other, then there would be only one tangent, right? Correct?
Yes, sir.
If the curves touch each
Yes.
other, then both the tangents are identical, and you can say angle of intersection here between the curves is 0 degree, because actually there are two tangents and both the tangents are the same. Correct?
Yes, sir.
1 second, hold on. I'm getting a call. I'll have to pause for 2-3 minutes. Just hold on, okay? Okay. Fine. I was talking about angle of intersection. So how do you find angle of intersection? You have to find the angle between the tangents. So anyway, if the point is given x1 comma y1 is the point, the slope of the tangent t2 would be what? If the curve was f2x, t2's slope, tangent t2's slope would be f2 dash x1. Is everyone agreeing?
Yes, sir.
And if the curve here was y is equal to f1x, the slope of this would be f1 dash x1, right? Correct? So if these are the two slopes, the angle between the tangents would be tan theta is mod of subtraction m1 minus m2 by 1 plus m1 m2, right? f2 dash x1 minus f1 dash x1 by 1 plus f2 dash x1 times f1 dash x1, right? Is everyone following what I'm saying right now?
Yes, sir.
Okay, so this is the way in which you find the angle of intersection between the curves. Many times the question becomes difficult because you first have to find the intersection point, right? So unless you find the intersection point, it will be difficult to find the angle of intersection. So for example, the question is this: find the angle of intersection between the curves x square y equals 4 and y times x square plus 4 equals 8. You need to mute yourself, whoever is on not on mute. You should unmute yourself only when you're talking. Right. So you have to find the angle of intersection between these two curves. So try it out. The first thing obviously is to solve the curves to find the point of intersection. How do you solve these two curves? It is easy.
Divide कर दें.
You can easily do it because it is x square plus 4 by x square eliminates the y term. So this is equal to 2. And from there, this question becomes easy because you're getting 2x square. So x square is equal to 4. So x is equal to plus minus 2. And if x is equal to plus 2, you will get y is equal to plus 1. So you get 2 comma 1. And if x is equal to minus 2, you will still get y is equal to plus 1. Right? These are my 2 points at which the intersection happens between the curves. Now, if I want to find angle of intersection at this point P, then I have to find the slope of both of the curves at this point. So what do? I find dy by dx for this. So how do I do that? I will differentiate. So I'll get 2xy plus x squared dy by dx equals 0. Do you understand what I'm doing here?
Yes.
By product rule, we are differentiating. We get dy by dx is equal to minus 2y by x. But we have to evaluate the slope at this point. So it will be minus 2 times 1 by 2. So minus 1 is the slope of the tangent to the first curve at this point. Similarly, the second curve, I will get dy by dx multiplied by x square plus 4 plus y times derivative of x square plus 4 is 2x is equal to 0. So our dy by dx for the second curve is coming minus 2xy by x square plus 4. And if you calculate that at 2 comma 1, you will get minus 4 by x square plus 4 is 4 plus 4, 8. So this is coming as minus half. So the slope of the tangent to the second curve at the same point is minus half. And now you can find the angle between them by doing m1 minus m2 by m1 plus m2. Our m1 and m2 are minus 1 and minus half. I hope this part is clear. There is no issue here, right?
Yes, sir.
Now, if
Yes,
you
sir.
know how to find the angle between curves, angle between C1 and C2, if the angle between them is equal to pi by 2, then we will say that curves C1 and C2 are orthogonal to each other.
Perpendicular.
Orthogonal to each other. So this is called orthogonal intersection. This means that the curves are intersecting in such a way that their tangents are perpendicular to each other. So basically, the angle was coming like this. Tan theta was f dash x minus g dash x by 1 plus f dash x g dash x, right? If f of x and g of x are the curves, this was the way in which we find tan theta, the angle between the curves, right? Correct?
Yes, sir.
So now if theta is supposed to be pi by 2, then tan theta is tending to infinity, right? For orthogonal intersection.
Right, sir.
If tan theta is tending to infinity, the only way in which that can happen is if this denominator tends to 0, right? So basically we have to say that f dash x and g dash x product is -1, which is what you would expect because the tangent slopes at that point must be perpendicular. Correct?
Yes, sir.
Slope of the tangent at those points has to be perpendicular, and that is what we are getting. Angle of intersection is 90 degree. So that is your basic theory for angle of intersection and orthogonal intersection. And that's about it from the point of view of tangents and normals. All of the stuff that we have discussed right now so far is useful in coordinate geometry. So if you are confused about these topics in circles or angle of intersection between random conic sections, you can use calculus directly. It's all connected and you can use the concepts here. So try to use it whenever you are stuck somewhere in coordinate, if you are stuck. The next major topic, which is coming under the purview of application of derivatives, is the idea of maxima and minima. Maxima and minima. So first of all, before we discuss maxima and minima, you need to understand what is an increasing or a decreasing function. Increasing, decreasing behavior of a function. So basically what that means is the function graph should be like this or like this. This is an increasing function. This is a decreasing function in some interval. By that we mean increasing function can be written as f of x1 is greater than f of x2 implies greater than equal to implies x1 is greater than equal to x2. That is an increasing function. So what this means is if x1 is bigger than x2, there is a double implication. Both sides are implied. So if x1 is greater than equal to x2, f of x1 is also greater than equal to f of x2 and vice versa. However, there are other types of functions where if x1 is greater than equal to x2, that implies that f of x1 is less than equal to f of x2. That would be a decreasing function. I hope everyone is familiar with these ideas.
Yes, sir.
Okay. So if you already know this increasing and decreasing, then you should also know the terms strictly increasing and strictly decreasing. So when you say strictly increasing, you don't have to put this equal to sign here. You have to say that if x1 is greater than x2, then f of x1 is greater than f of x2 and it cannot be equal. So when we say increasing, we can always include a constant function as an increasing function. But when we say strictly increasing, it cannot be constant over any interval. It has to be higher. Is that clear what I'm saying?
Yes.
Now, if you know this increasing, decreasing, strictly increasing and strictly decreasing functions, then what we can understand from here is that you can characterize all of these functions by thinking about their derivatives. You can see here that the graph of an increasing function is like this, and the slope of the tangent is increasing and is always positive. This is positive slope, this is positive slope. Slope of the tangent is not increasing. What I meant was slope of the tangent is always positive. If the slope is positive, then the function is increasing in that region. Similarly here, slope of the straight line for a decreasing function is always negative slope. This is negative slope because it makes greater than 90-degree angle with the positive x-axis. These lines are making big angles with the positive x-axis. which are greater than 90 degree. Technically, these angles are greater than 180 degree here in this case. And that case, tan theta is negative. Therefore, these are negative slope. Whenever you have a negative slope for a particular function, that means it is decreasing. So the concept of derivatives is becoming useful for us even in predicting the values of a function. We can see the trend or the pattern in a function's values if we know the derivative and how the derivative behaves. If the derivative is positive, the function is increasing. If the derivative is negative, the function is decreasing. Now, why are we mentioning all this right now when I wanted to talk about maxima, minima? The point is that anytime you approach a maxima, you should realize that the function was increasing and it then started decreasing, right? So the point is called a local maxima. Local because it is a maxima in this neighborhood. It's a local maxima because it the function goes from an increasing function to a decreasing function. So what we know is that the derivative was positive here, but it became negative here. So the derivative of the function f dash x changes sign from positive to negative. Positive to negative. And you can see visually that that will be a point for local maxima. I hope everyone is understanding what I'm saying right now.
Yes, sir.
And if you look at an alternative point where the function was decreasing and increasing, then this point Q will be a local minima. And the reason for that is that f dash x was negative here and f dash x is positive here. So the graph was decreasing and then it started increasing. Correct? I hope it is clear so far what we have done.
Yes, sir.
So if somebody tells you that how to identify the maxima or minima of a particular curve, all you have to do is to think about where the derivative will change the sign. If the derivative goes from positive to negative, it's a maxima. If the derivative goes from negative to positive, it's a minimum. Correct? Is that clear so far?
Yes, sir.
So far, we have not used the double derivative test for maxima minima. So basically, there are two ways to test maxima minima. One way is find f dash x and set it equal to 0. Find the points x is equal to alpha, beta. It could be multiple points where the first derivative becomes 0. Why are these points important for us? The reason they are important is whenever a curve attains a maxima or a minima, the derivative were positive and then it became negative. So the derivative itself, this is the point where the derivative is 0, right?
Yes, sir.
The derivative is 0 at the point where the value of the derivative switches from positive to negative or negative to positive. So once you have found 2 points, let's say P and Q, you have found 2 points. Now you can see these are the points where the derivative is 0 at P and Q, right? After this, you have to decide whether we have a maxima or a minima here. And the same thing for Q also, whether we have a maxima or a minima. Now, even if you don't want to calculate the double derivative, you can still get away with this much because you can find single derivative and keep a track of how it changes its sign. Keep a track of how it goes from positive to negative or the opposite. then only you can have a maxima and a minima, right? Only if the graph is turning, and then only you will be able to say that this is a maximum. Correct? Why is it important to understand that? Because sometimes the function might be very complicated and double derivative is not possible. So you can still find maxima or minima by analyzing the first derivative, where the first derivative was 0, how the function was before the first derivative, and how the function was afterwards. So you need to understand whether the derivative changes sign or not. If the derivative is changing sign, then it could be a maxima or a minima. And again, from the graph and from your understanding, you can figure out whether the sign of the derivative changes and in what way it changes. I hope you're not confused by what I'm saying so far.
Yes, sir.
You are not confused, right? Everything is clear.
Yes, sir.
Yes, sir.
So far, I have not used double derivative at all. What I'm saying is only with a single derivative, I can find where it is maxima and minima. And that I was able to do here because I understood what is the sign of f dash x and how it changes. The second method is faster sometimes, but sometimes it might be slow. What you have to do is f dash x is equal to 0 and find the points where this happens. Find the points where f dash x is 0. These points are known as critical points, by the way. Critical points are the points where either the function is not defined at those points, or two, where f dash is equal to 0. Correct? Now, once we have found these critical points, maxima and minima can only happen at the critical points. So if maxima and minima is happening, we can just figure out f dash x's sign and how it changes, whether it goes from positive to negative or negative to positive. If it is going from positive to negative, then automatically you know that the function was behaving in what way? Is that point a point of maxima or minimum? So when your derivative sign goes from positive to negative, what kind of graph is it going to be?
It will be a maximum.
Right. It will be a maxima. And if it is negative to positive, it will be a minima, right? So when I say it goes from negative to positive, I mean a small portion of the graph just before and just after the point x is equal to, let's say, a. So just after and just after, what is just before and just after? What is the range of the values of f dash x? Is it positive, negative, what? So if we can figure that out, then we can automatically find maximum, minima. The other method is f dash x is equal to 0, find the double derivative. Double derivative at the critical points. At the critical points, if you find the double derivative, if the double derivative is greater than 0, it's a minima. And if the double derivative is less than 0, it's a maximum. Why is this so? Because the double derivative tells us whether single derivative function is increasing or decreasing, right? Correct?
Yes, sir.
Yes.
So if the single derivative was increasing, then double derivative is positive, right? If it was increasing, it would be positive. If the single derivative was decreasing, it would be negative, right? Double derivative. Correct?
Yes, sir.
So you can also call this phenomena as you get to know the shape of the curve. Shape of the curve. by doing double derivatives. So if the curve is shaped like this is called concave up. And if the curve is shaped like this is called concave down. So here concave up will be the situation where double derivative is greater than 0, and concave down would be when double derivative is less than 0. The reason for that is easy. If you think about it geometrically, you can see that the slope here was negative, here the slope was 0, and here the slope is positive, right? Do you understand what I'm saying?
Yes, sir.
The slope was negative, 0, and positive. So clearly slope is increasing, no? Slope of the curve. And slope of the curve is increasing means double derivative is positive, right? I hope that connection everyone can see geometrically also, not just in terms of equations. You need to realize that this is common sense stuff. Correct?
Yes, sir.
Yes, sir.
Okay. Now, think about this type of curve. Notice here what is happening. The slope was positive, single derivative, slope was positive, slope is reduced. The tangent has a lesser slope, and here let's say the slope has turned and it has become negative. So here the slope f dash is decreasing clearly. And if f dash is decreasing, then that means we call that a concave down. Basically, double derivative is positive, then it is concave up. Double derivative is negative, then it is concave down. Right? Now, that gives us another condition to quickly do maxima minima, because we can just check double derivatives of the relevant functions. However, don't always rely on the double derivative in problems, because sometimes the function is so complicated that it will be annoying to do double derivatives and all. Correct?
Yes, sir.
Yes, sir.
So now think about it. So far, what we have discussed for increasing, decreasing functions and maxima minima, try to do this proof. Prove that 2x by pi is less than sine x is less than x when x belongs to 0 to pi by 2. Try to do this question first. Anybody who has the idea or who is able to do, please let me know. Tell me if you have gotten it.
तो डिफरेंशिएट करके आ जाएगा।
कैसे करोगे? कैसे आ जा रहा है?
सर मतलब दो केस लेंगे, पहले वो साइन एक्स लेस देन एक्स वाला एक, फिर वो साइन एक्स ग्रेटर देन 2x बाय पाई वाला एक।
नहीं,
वो
मुझे समझ में नहीं आ रहा है मतलब क्या है इसका। इसको अस्यूम थोड़े कर सकते हैं, प्रूव करना है। ये प्रूव करना है ना, अस्यूम थोड़े करना है। समझ में आ रहा है मैं क्या बोल रहा हूँ?
यस सर।
तुम असम्पशन ही कर लोगे तो फिर प्रूव क्या कर रहे हो?
Sir, curve of x is always above the sin x curve, so x is always greater than sin x. We can say in
Again,
0 to pi by 2.
again, that is an assumption. what you have just said is, how do you know that curve of x is always above sin x?
Because at x equal to 0, derivative of sin x and is actually at x equal to 0, the slope of x and sin x is same 0.
Mm-hmm.
But after बट x के बाद जो उसका स्लोप आएगा तो मतलब y इक्वल टू x का स्लोप ज्यादा होगा तो ये इंक्रीजिंग है।
वो
Both the
sin x
functions
by
are increasing.
sin x by x जो डिक्रीजिंग फंक्शन होगा तो f of z तो फिर वो इनइक्वालिटी लगा सकते हैं डिक्रीजिंग फंक्शन वाला।
तुमको कैसे पता sin x by x decreasing function?
सर वो डिफरेंशिएट करके निकाल सकते हैं।
तुमने क्या किया है अभी तक?
सर जैसे f of x आप ऐसे ले सकते हैं sin x by x, तो फिर f dash x निकालने पे वो नीचे
हम्म
x स्क्वायर आ जाएगा
और
और
ऊपर क्या आ गया?
ऊपर sin x माइनस x cos x।
नहीं,
हाँ sin x माइनस x cos x।
x cos x minus sin x।
तुम
हाँ
डिफरेंशिएट गलत करोगे तो कैसे होगा भाई?
हाँ उसके बाद अब ये
वन
इसको
सेकेंड वन सेकेंड वन सेकेंड रुक जाओ एक सेकेंड। तुमको लगता है कि तुम डिफरेंशिएट sin x माइनस x cos x करके क्वेश्चन सही होगा फिर?
नहीं सर वो तो रिजल्ट याद था, वो
क्या याद था?
रिजल्ट याद था sin x by x डिक्रीजिंग होता है।
लेकिन डेरिवेटिव गलत क्यों हो रहा है?
तो वो थोड़ा हो गया गलती से।
क्वेश्चन रूल में गलती होगा।
थोड़ा।
ऐसा ये सब चीज अलाउड नहीं है, क्वेश्चन रूल में गलती करना अलाउड नहीं है।
हम्म
एग्जाम में जरूरी नहीं है कि sin x बाय x फंक्शन ही आएगा जिसका तुमको रिजल्ट याद रहेगा, राइट?
हाँ
You need to be able to take derivatives correctly.
राइट।
What happens now after this?
तो सर फिर जीरो ग्रेटर देन एक्स, सॉरी एक्स ग्रेटर देन जीरो लेस देन पाई बाई टू हो जाएगा।
Okay, so
हाँ तो फिर एफ ऑफ जीरो, अब इनइक्वालिटी रिवर्स हो जाएगा, एफ ऑफ जीरो ग्रेटर देन एफ ऑफ एक्स ग्रेटर देन एफ ऑफ पाई बाई टू।
अभी तुमको ये कैसे पता चला कि f डैश x इंक्रीजिंग है कि डिक्रीजिंग?
सो वो बोले तो वो रिजल्ट याद है मतलब। और आप इधर से भी देख सकते हैं एक्स कॉस एक्स माइनस साइन एक्स, इसको भी डिफरेंशिएट करके फिर पता चल जाएगा इसका क्या बिहेवियर है। पॉजिटिव होता है ऑलवेज, सॉरी नेगेटिव होता है ऑलवेज।
हम्म बहुत सारे असम्पशंस ही चल रहे हैं तुम्हारे, कोई चीज तुम ठीक से बोल नहीं रहे हो, बस असम्पशंस ही
नहीं
बता
तो
रहे हो
वो
मुझे।
तो वो मेरे को रिजल्ट आया था तो आपको प्रूफ बता रहे थे। तो अच्छा तो एफ डैश वो न्यूमरेटर को डिफरेंशिएट करने पे cos x cos x माइनस cos x ही हो जाएगा फिर। हम्म,
This is my
हाँ सर।
derivative. This is positive. This is negative. So f dash x is negative. So now we know that this function is decreasing. And if this function is decreasing, then we can take several values. We can say that f of 0 will be bigger than f of x will be bigger than f of pi by 2, where 0 is less than x is less than pi by 2 because the function is decreasing, right?
यस।
F of 0 here, if you try to put 0, it is coming in 0 by 0 form. But if you understand limits, then you know that this will be limit is tending to 1, right?
Yes, sir.
Yes, sir.
So you will get 1 is greater than sin x by x is greater than sin pi by 2 is 1 over pi by 2. So you are getting 1 is greater than sin x by x is greater than 2 by pi. And now you get the proof. If you cross multiply with x, you will get 2x by pi. You will get basically x is greater than sine x is greater than 2x by pi. So we are proving this question not by just assuming that yes, it is already happening. We are proving it by checking a function, taking an appropriate function and showing that the function is decreasing when x lies in this range. And if the function is decreasing, then you can always make inequality like this. When the input becomes bigger, function's value should become smaller for a decreasing function. Is it clear what we have done to do this problem?
Yes.
The next question is this one. For the function f of x is equal to x power x, find the points where it is increasing or decreasing. It is increasing or decreasing. First, do that, and second, use that to find which one is bigger. Which one is bigger, e power pi or pi power e? इन दो नंबर्स में से डिसाइड करना है कि कौन सा नंबर बड़ा है. बट ये कैसे होगा, ये पार्ट 2 है. पहला पार्ट है इस फंक्शन के बारे में इंक्रीजिंग और डिक्रीजिंग बिहेवियर पता करना है, तो वो पहले करो.
Sir, x की power x is increasing in 1 by e से infinity or decreasing in 0 से 1 by e.
If you do the
Sir, हमको
derivatives properly, it will come increasing in 1 by e to infinity and decreasing in 0 to 1 by e.
सर हम x की पावर x को e की पावर x ln x लिख सकते हैं वैसे करके की.
हाँ,
फिर
अब हम
डिफरेंशिएट.
लोग रुको एक सेकेंड. तुम ये डिफरेंशिएट और डिफरेंशिएशन कैसे कर रहे हो ये बता रहे हो?
सर x की पावर x को वो e की पावर x ln x करके फिर किया मैंने.
x ln x, ओके, दैट्स करेक्ट. फिर डिफरेंशिएशन इसको कर रहे हो,
यस सर, फिर वो चेन रूल वगैरह.
ओके. डिफरेंशिएशन इसको करोगे तो होगा e पावर x ln x टाइम्स ln x प्लस x into 1 by x, right?
Yes.
So this part is always going to be positive, so you only have to care about this part, right?
Yes.
तो उससे आ जाएगा 1 by e is the point where it will change the sign. Great. So 1 by e के आगे the function is an increasing function, right?
Yes.
Correct. और 1 by e से पहले it was decreasing. Now देखो, अगर ये पता करना है कि which one is bigger, right? तो इसमें ऐसा सोच सकते हो कि f of x अगर ये है, उसमें f of 1 by e और f of 1 by pi का वैल्यू निकालना है मान लो, राइट? करेक्ट?
Yes.
f of 1 by e क्या होगा? 1 by e to the power 1 by e, राइट? और
Yes.
ये होगा 1 by pi to the power 1 by pi, राइट? करेक्ट?
Yes. Sir.
और तुम देखोगे कि 1 by pi is actually smaller than 1 by e, no?
Yes, sir.
1 by pi is lesser than 1 by e. तो उस
Yes.
रेंज में तो फंक्शन was decreasing, right?
Yes, sir.
So we can say that f of 1 by pi should be bigger than f of 1 by e,
Yes, sir.
right?
Yes, sir.
Correct? So अब उससे ये पता चल रहा है कि this part is bigger than this, right? तो ये हो रहा है 1 by pi power 1 by pi is bigger than 1 by e power 1 by e, right? So this becomes 1 by pi power 1 by pi is bigger than 1 by e power 1 by e. So cross multiplying, you'll get e power 1 by e is greater than pi power 1 by pi, right? समझ में आ रहा है क्या लिख रहे हैं?
Yes, sir. Yes, sir.
Yes, sir.
एंड
Yes, sir.
होल थिंग को कॉमन पावर ऑफ पाई ई पे रेज कर देंगे, राइट? So then you will get e power 1 by e times pi e is greater than pi power 1 by e times pi e, and you will end up with e power pi is greater than pi power e. Correct?
Yes.
Usually इस वाले जो फंक्शन से ये चीज करना is more trickier. I would have preferred to use a function like this, x power 1 by x. That is a better function to do this, no?
Yes.
Because उसमें डायरेक्टली g of pi और g of e को कंपेयर करना है, right? Do you understand what I'm saying? I would have used this function, but in the problem here they wanted us to use this function. तो यहाँ पे input 1 by pi और 1 by e देना पड़ गया, right?
Yes.
Is everyone understanding what we have done so far?
Yes, sir.
Okay, so
Yes, sir.
that is your basic concept of maxima minima so far. Now some of the things that we have discussed here, let's do one more question maybe. Let me look at a nice question. Hmm. Okay, not a very difficult question, but try this one. Find the point at which f of x is equal to sine to the power mx multiplied by cos to the power nx has maximum value. Here m and n are greater than 0. Where is the point of maxima for this function? Try to find that.
Sir, x equal to tan inverse root m by n.
ठीक है, बाकी लोग को भी हो जाना चाहिए. इट विल टेक सम टाइम बट इट शुड कम लाइक दिस. This is the point of maxima. You have to do single derivative and you can check whether the double derivative is positive or negative. Double derivative should become negative for maxima. Single derivative should be 0. I am not going to spend time doing this because this is basic differentiation. So ये तो खुद भी कर लोगे, आंसर यही है. ठीक है. Next question is find the values of P if f of x is equal to cos x minus 2px is invertible. Does everyone know what is the meaning of invertible? What is an invertible function?
जिसका इनवर्स पॉसिबल है.
उससे कोई फायदा हुआ ये जो तुमने बोला है उससे? वो तो सबको पता है यार, वो तो वर्ड का ही मतलब है.
सर स्ट्रिक्टली मोनोटोनिक होगा फंक्शन.
कंडीशन क्या है इन्वर्टिबल का? इनवर्स पॉसिबल है वो तो क्लियर ही है, उसके आगे क्या कंडीशन है उसके लिए? स्ट्रिक्टली मोनोटोनिक
डेरिवेटिव
होगा.
का साइन चेंज नहीं होना. डेरिवेटिव का साइन चेंज नहीं होना चाहिए.
मोनोटोनिक जो बोल रहे हो उसका मतलब क्या होता है? मोनोटोनिक होता है उसका मतलब क्या है?
स्ट्रिक्टली मोनोटोनिक मतलब एक ही बिहेवियर होगा, या तो इंक्रीज कर रहा होगा या तो डिक्रीज.
उससे इन्वर्टिबल का क्या रिलेशन है?
सर तो वो हर मतलब सारा यूनिक पॉइंट होता है, तो मतलब ये इनवर्स एग्जिस्ट कर जाता है उस केस में. जैसे मतलब एक एक एक्स के लिए दो वैल्यू नहीं आता वाई का
फंक्शन को
वैल्यू.
1 to 1 होना चाहिए.
1 1 on 2 होना चाहिए ये बोलना है, राइट?
हाँ, 1 1 and 1 2.
दैट इज द कंडीशन फॉर इन्वर्टिबल फंक्शन. और मोनोटोनिक फंक्शंस जब होते हैं तो 1 1 हो जाता है, राइट? करेक्ट. और यहाँ
यस
पे
सर.
क्योंकि ये लीनियर फंक्शन है यहाँ पे, तो ये ऑन टू एनीवेज है. Nobody has told us the codomain, so we don't have to worry about the onto part here. Do you understand that in the problem they have not mentioned codomain? They have not mentioned codomain, no? Usually ऐसा होता है ना, ऐसा कुछ दिया जाता है A to B या R to R ऐसे करके, राइट?
यस सर.
अगर ये दिया होता तो मेरा B होता कोडोमेन, राइट?
यस सर.
और अगर ये दिया होता तो फिर हम लोग को रेंज चेक करना पड़ता, एंड वी हैड टू चेक वेदर रेंज इज इक्वल टू कोडोमेन और नॉट. करेक्ट.
यस सर.
बट यहाँ पे तो कुछ बताया ही नहीं है फंक्शन का कि कहाँ से कहाँ डिफाइंड था. तो वी विल अस्यूम दैट इट इज डिफाइंड फॉर ऑल रियल्स and it is defined from R to R. That is an assumption that we are making. Correct? क्योंकि कुछ बोला नहीं गया है, right? You should also realize that the range of the function is all real numbers. Why? cos तो बाउंडेड फंक्शन है, लेकिन 2px जो लिनियर पार्ट है उसके कारण वो ऑल रियल्स को टच कर जाएगा, राइट? Is everyone understanding what I'm saying?
Yes, sir.
So because ये 2px linear part is going to make its range go to all reals, we can here forget about the onto condition. Otherwise अगर specifically question में mentioned होता A set और B set, तो we have to worry about onto condition then. So here we are forgetting about onto and we only focus on the 1 1 part, and 1 1 function hoga if it is monotonic, if it is strictly increasing or strictly decreasing. So now the question is basically find the values of p so that it is strictly increasing or strictly decreasing. In that case, it becomes invertible. So find the answer then.
So p greater than half.
That's incomplete answer. It is correct, but it's not complete.
P greater than half and P less than minus half.
ग्रेटर देन इक्वल टू बोल सकते हैं. मोनोटोनिकली इंक्रीजिंग जब बोलते हैं तो उसमें स्ट्रिक्टली इंक्रीजिंग नहीं जरूरी है. We have to say f dash x is greater than equal to 0 or less than equal to 0. Right? No, actually we should say greater than, not strictly ही बोलना है. Because constant function will not be 1 1. So we have to make sure this happens. So उसमें condition तुम्हारा आएगा p greater than half or p less than minus half. You should get mod p greater than half. Is it clear?
Yes, sir.
Okay, तो वो होगा आंसर तुम्हारा. Now the next one is find the values of a if f of x is equal to 2 e power x minus a e power minus x plus 2a plus 1 times x minus 3 is always increasing.
Sir,
बोलो.
sir, in the previous question, कोई इंस्टेंट पे तो जीरो हो सकता है ना डेरिवेटिव, तो उसको तो कंसीडर करना पड़ेगा.
मोनोटोनिकली इंक्रीजिंग फंक्शन में डेरिवेटिव इज पॉजिटिव ऑलवेज.
ऑलवेज.
इंक्रीजिंग फंक्शन में डेरिवेटिव जीरो कैसे होगा? जीरो पे कांस्टेंट हो जाएगा.
नहीं मतलब कोई इंस्टेंट पे जीरो तो हो सकता है ना.
फंक्शन का वैल्यू जीरो होना और डेरिवेटिव जीरो होना में डिफरेंस है.
नहीं मैं बोल रहा हूँ कि फंक्शन पॉजिटिव होगा, मतलब फंक्शन का डेरिवेटिव पॉजिटिव होगा, बट कोई इंस्टेंट पे वो जीरो भी हो सकता है.
नहीं, क्यों जीरो होगा?
एक्स की कोई वैल्यू पे जीरो हो सकता है.
कैसे जीरो होगा बताओ तो थोड़ा. अगर
अ,
डेरिवेटिव जीरो हो गया तो फिर उसके आगे क्या होगा वो?
उस पर्टिकुलर टाइम पे वो हॉरिजॉन्टल हो जाएगा, बट उसके बाद तो इंक्रीज कर ही सकता है ना.
नहीं, पूरा गलत कॉन्सेप्ट है. थोड़ा
सर
ध्यान से थोड़ा थोड़ा सा कामली थोड़ा सा सोचो तो क्या तुम बोल रहे हो. मान लो डेरिवेटिव जीरो हो रहा है, तुम बोल रहे हो एक्स इज इक्वल टू 5 पे. एक्स इज इक्वल टू 4 पे क्या था डेरिवेटिव का वैल्यू?
हम्म, नहीं
और
सर,
और 6 पे क्या है? तुम मुझे तुम्हारे हिसाब से एक पॉइंट पे जीरो हो सकता है ना.
यस सर.
तो नेक्स्ट पॉइंट्स पे बताओ ना. 6 पे बताओ और 5 पे बताओ कैसा होना चाहिए.
तो पॉजिटिव वैल्यू.
दोनों तरफ पॉजिटिव.
सर एक तरफ नेगेटिव है ना, एक तरफ पॉजिटिव.
तो वो इंक्रीजिंग डिक्रीजिंग ऑलवेज इंक्रीजिंग कैसे होगा अगर नेगेटिव होगा तो?
Sir, a greater than
सर
equal.
बट इन्वर्टिबल होने के लिए तो उसका कंडीशन नहीं है ना कि वो स्ट्रिक्टली इंक्रीजिंग या फिर स्ट्रिक्टली डिक्रीजिंग होना चाहिए.
तुमने हम लोग ने जो भी डिस्कशन किया था वो कुछ सुना नहीं है तुमने. इन्वर्टिबल होने के लिए स्ट्रिक्टली इंक्रीजिंग और स्ट्रिक्टली डिक्रीजिंग नहीं हो रहा है वो.
सर एक्स क्यूब जो है वो तो एक इन्वर्टिबल फंक्शन है,
हाँ, फिर
तो उसका ग्राफ तो जीरो होता है, उसका स्लोप एट एक्स इक्वल टू जीरो पे।
x इज इक्वल टू जीरो पे स्लोप जीरो हो रहा है तुम्हारा।
हाँ, एक्स क्यूब का जो ग्राफ है उसे आप चेक करके देखिए।
That is an inflection point that the derivative, double derivative is also zero there. That is a different kind of point. डबल डेरिव उसमें मैक्सिमा मिनिमा होता है क्या एक्स क्यूब के ग्राफ पे?
सर एक्स क्यूब का ग्राफ का मैक्सिमम मिनिमा तो नहीं होता, बट वो तो इन्वर्टिबल फंक्शन है ना, तो मैं मैक्सिमम मिनिमा की बात नहीं कर रहा हूँ, मैं इन्वर्टिबल होने की भी बात कर रहा हूँ। मतलब एक्स क्यूब भी तो वन वन फंक्शन है, ऑन टू फंक्शन ही है, और एक्स इक्वल टू जीरो पे वो भी जीरो हो रहा है, उसका मतलब स्लोप
एक्स क्यूब का डेरिवेटिव क्या है?
टू एक्स स्क्वायर।
हम्म। और टू एक्स
तो
स्क्वायर
एट एक्स इक्वल टू जीरो, ये तो जीरो हो रहा है।
तुम्हारा पॉइंट क्या है अभी?
मैं ये बोलना चाहता हूँ कि पिछले जो मतलब क्वेश्चन था उसमें हमने इक्वल टू जीरो को कंसीडर नहीं किया, सिर्फ ग्रेटर पी ग्रेटर देन ही कंसीडर किया। मतलब स्लोप को हमने सिर्फ ग्रेटर देन जीरो या फिर लेस देन जीरो किया, बट कुछ कुछ इंस्टेंस पे वो जीरो हो सकता है, जैसे कि यही एक एग्जांपल हो गया।
हाँ, इन्फ्लेक्शन पॉइंट्स पे हो सकता है जहां डबल डेरिवेटिव इज जीरो, वहां पे हो सकता है। इफ द
हाँ सर,
फंक्शन
मैं
हैज एन
वही बोल रहा
इन्फ्लेक्शन
था।
पॉइंट then it can be zero, but it cannot be zero in a normal situation. अगर इन्फ्लेक्शन पॉइंट नहीं होगा तो फिर इस साइड तुमको पॉजिटिव होना है तो जीरो कैसे होगा फिर? बिकॉज नॉर्मली व्हेन f dash x is zero, you will usually have a turning point.
यस सर।
समझ रहे हो? 90% ऑफ द केसेस में जब डेरिवेटिव जीरो होता है तो फंक्शन इज टर्निंग।
यस सर।
और फंक्शन टर्निंग हो तो इन्वर्टिबल है क्या ये?
ये इन्वर्टेबल नहीं है, बट प्रीवियस वाले केस में तो हमें पता नहीं है ना कि वो क्या था होगा।
तो वही मैं बोल रहा हूं कि you have to be sure whether it is a function which is turning, whether it is an inflection point or whether it is not an inflection point. The only place where you can have a increasing function where f dash x is zero somewhere is if it's a inflection point यहाँ पे जो हो रहा है।
ओके सर।
अगर अगर वो टर्न कर जाएगा फंक्शन, उसके बाद क्या होगा? अगर टर्न कर जाएगा तो इट्स नो लॉन्गर इन्वर्टिबल, राइट?
हाँ, टर्न करेगा तो वन टू वन, वन वन नहीं होगा।
If you have positive and negative on the two different sides, you cannot be 1 1 then.
हाँ सर।
So basically, the point is that a particular point doesn't matter. What matters is whether the derivative is not changing sign before and after a particular point. Do you understand what I'm saying?
यस सर।
F dash x का sign cannot change before and after any point. The particular point का value doesn't even matter. What matters is पॉजिटिव अगर है तो इधर भी पॉजिटिव होना है, नेगेटिव अगर है तो इधर भी नेगेटिव होना है पॉइंट के बाद।
यस
Because
सर।
if the sign changes, it is not going to be 1 1.
यस सर।
Anyway, the second question क्या आ रहा है आंसर?
A belongs to real number, the positive real number.
A greater than equal to 0 आना चाहिए, राइट?
Yes, sir.
सबको आ रहा है वो? Is everyone getting that question? The question that I written about e powers and all. Okay, fine. The next one is this one. let fx and gx be two continuous functions defined from R to R. It is given that f of x1 is greater than f of x2 and g of x1 is less than g of x2 for all x1 greater than x2. You have to find the solution set of f of g of alpha square minus 2 alpha is greater than f of g of 3 alpha minus 4. इस इनइक्वालिटी का सॉल्यूशन निकालना है.
So alpha belongs to 1 to 4.
इतना जल्दी कैसे आ रहा है बताओ.
सर वो f इंक्रीजिंग है, g डिक्रीजिंग है, तो डायरेक्ट स्क्वायर माइनस 5 अल्फा प्लस 4 बन गया. उसका रूट से याद था मेरे को. 1 और 4 है, तो जब नेगेटिव होता है तो डायरेक्ट आ जाता है ना 1 से 4 के बीच में.
ये दिख रहा है ना सबको कि f इंक्रीजिंग है और g डिक्रीजिंग है. That should be clear to everyone from here. If f is increasing, then look at the outer function. f का फंक्शन को हटाओगे तो ऐसा आना चाहिए g of alpha square minus 2 alpha is greater than g of 3 alpha minus 4. If you remove the f, right? क्योंकि f increasing था. उसके बाद g decreasing है तो इससे आना चाहिए alpha square minus 2 alpha. इसमें साइन रिवर्स होना चाहिए. I hope everyone is understanding.
Yes, sir.
Yes.
और उसके बाद क्वेश्चन बन जाएगा, यही आंसर है. फाइनल 2 क्वेश्चंस ये होमवर्क में करना. ये 2 क्वेश्चंस. प्रूव दैट mod of cos alpha minus cos beta is less than equal to alpha minus beta. And second question है for 0 is less than x is less than pi by 2, prove that cos of sin x is greater than sin of cos x. ये 2 क्वेश्चंस करना. We will possibly discuss a few more questions in the next class, and we also have to do, so the plan for the next class is a few more questions on AOD, plus we also have to do the theoretical calculus part. And by theoretical calculus, I mean Rolle's theorem, LMVT, and Cauchy's mean value theorem. So these 3 things we will discuss. Some parts of it are not in the syllabus, I think. They have excluded it in JEE mains, but we can't trust them, so we have to study it anyway. ये शायद ये पूरा एक्सक्लूड हो गया है क्या, बताओ तो, किसी को पता है?
यस सर, मीन वैल्यू थ्योरम्स नहीं है सिलेबस में.
हाँ, तो रोल्स थ्योरम भी एक्सक्लूडेड है.
हाँ, कोई भी मीन वैल्यू थ्योरम नहीं है.
तो okay, but they have asked questions in the last 2 years, so, and anyway it is in the advanced syllabus, so we will discuss it. Try these 2 questions, solve these 2. We next class we'll try to finish this theoretical calculus stuff, and we'll do some more problems and finish the theory for AOD. So theory for AOD will be done. After that you are supposed to attempt the sheets, and in the coming week we'll be doing the straight lines and circles theory also. So work on it. All the sheets are already sent on the group, so make sure that you try the sheets. The discussion classes that we will have next week will be useful only for those students who actually attempt the sheets. तुम करोगे नहीं attempt तो फिर कोई फायदा नहीं होगा उसका. Is it clear, everyone?
Yes, sir.
Yes, sir.
Okay, so try the questions there, and we'll try to do one session on Monday, which will finish all this. Okay. So that's it for now. I'll see you next class.
Thank you, sir.
Bye.